We're going to continue working with higher roots today. Here we're considering the cube root of x to the fourth. And the cube root of x to the fourth, well, 3 goes into 4 once, so it'll be x to the first on the outside with 1 left over. And so x to the first on the inside. So the cube root of x to the fourth becomes x times the cube root of x. If we look at the fourth root of x to the seventh, well, 4 goes into 7 once, so it'll be x to the first on the outside with 3 left over. So it'd be x cubed on the inside of the fourth root. Now I do want to make sure you understand that where all this is coming from, so just another way of thinking about this. X to the fourth is x cubed times x. And the cube root of x cubed is just x. And here's the 1 left over. If we were thinking about x to the seventh in terms of fourths, it would be x to the seventh is the same thing as x to the fourth times x cubed. Well, the fourth root of x to the fourth is just x to the first. Here's the x cubed left over. So I still think the Orndorff method is a convenient way of thinking about it. That's kind of the better reason behind it. Why don't you try these two? The fourth root of y to the sixth, and then try the third root of z to the fifth. What do you come up with? Hit pause. Let's check it out. 4 goes into 6 once, so it'd be y to the first on the outside, and the fourth root of y squared, the 2 left over on the inside. The cube root of z to the fifth, well, 3 goes into 5 once, so it'll be z on the outside, and the cube root of z squared for the 2 left over on the inside. We can think about this in terms of numbers. Let's break down the cube root of 16. Well, if we're dealing with cube roots, it's best to think of perfect cubes. And 16 is 8 times 2. And 8's really helpful because 8 is 2 cubed. So the cube root of 8 is 2 times the cube root of 2. Let's think about another one. The fourth root of 243. 243, I'm going to do some work here on the side to maybe break this down. 243 is not divisible by 2, but it is divisible by 3. It's 3 and 81. And 81 is an important number when you're dealing with perfect fourths. It's 3 to the fourth. So I have the fourth root of 81 times 3. But the fourth root of 81 is 3 times the fourth root of 3. Right? These numbers are going to get used over and over and over again. Let's try 2 more. The cube root of 81. So you want to think about perfect cubes. And the fourth root of 64. So you want to think about perfect fourths. Hit pause and see what you can do with them. Here's how I would think about them. 81 is the same thing as 27 times 3. And 27 is a perfect cube. It's 3 cubed. So this is 3 from the cube root of 27 times the cube root of 3 from the 3 there. 3's. Fourth root of 64. Well, my perfect fourths are 1. 2 to the fourth is 16. 3 to the fourth is 81. So the only numbers that matter are these two. Because once I get to 3 to the fourth, it's too big. Well, 64 is the same thing as 16 times 4. And the fourth root of 16 is 2. So this would be 2 times the fourth root of 4.